Okay. Honors Algebra, Section 5.1, Midsegment Theorem and Coordinate Proofs. First theorem of the chapter is Theorem 5.1, or the midsegment theorem. Let's first talk about what a midsegment is. So we have a triangle here, and we have a triangle ABC. And of side AB, we have this point that's exactly in the middle, the midpoint of ABC, and we're going to call that point M. Of side BC, we have the midpoint of side BC, which is point B, or P, and then side AC, we have the midpoint, which is point N. Midpoint meaning they cut these guys directly in half, so AM would be congruent to BM, BP would be congruent to PC, and AN would be congruent to NC. These are all the midpoints. And if I was to draw a line from N to N, this line here would be the midsegment. If I was going to draw a line from M to P, this line would be the midsegment. If I was going to draw a line from P to N, these lines would be the midsegment. So the midsegment in this case would be MP, PN, and MN. Okay. Midsegment of a triangle is the segment that connects the midpoints of two sides of the triangle. Every triangle has 3 midsegments. Again, 3 midsegments because they connect the midpoints of two sides of the triangle. So here's one side, here's the other side, this MN connects them to. This side and this side, NP connects the two. This side and this side, NP connects the two. Which leads us to the midsegment theorem. Actually, let me finish this off. Midsegment connects two sides of a triangle. At the midpoint of those two sides. And there are 3 midsegments in a triangle. Okay, and again that leads us to the midsegment theorem. And the midsegment theorem says this. It says that the segment connecting the midpoints of two sides to the triangle is parallel to the third side and is half as long. So thing number 1, midsegment is parallel to the third side. Midsegment is parallel to the third side. So if I look at side MP, MP is parallel to AC. Those guys are parallel. NP is parallel to AB. MN is parallel to BC. They're always parallel to the third side. Not only that, the midsegment is always half the length of the third side as well. Okay. Midsegment is parallel to the third side. Midsegment is half the length of the third side. If we look according to this, we can say that MP is parallel to AC. We can also say that AC is equal, we can say that MP is equal to half of AC, half of the third side. Or we can say that, oh yeah, that's right, we have equal signs. MP is equal to half of AC, or we can say that 2AC is equal, 2MP is equal to AC. Either way works. Yeah. So this can be used in basic algebraic stuff. This says suppose the distance of UW is 81, find VS. This is UW. UW is the midsegment of this guy. If this is 57, then this is 100. Do they give me the distance of ST anywhere? Oh yeah, doy. I don't need ST. Okay, so let me draw this triangle. We have triangle here. We need S, T, and R. We have, this is not to scale, of course. We have U, we have V, we have W. We're told that UW is equal to 81 inches. Well, I know that UW is the midsegment. So I can use the midsegment theorem because I know the third side of UW is ST, and I know that UW is equal to 1/2 ST. So if I want to find out what ST is, I'll just multiply it by 2 on both sides, and I can say 2 times UW equals ST. So then I can say that 2 times 81 equals ST, and 2 times 81 is 162 inches. Okay. So that's how you can use the midsegment algebraically. Here they said that all these guys are midsegments of each other, so A, C, B, D, F. They're midpoints and mid segments of the bigger triangle, and they want us to find that they're parallel or not by the definition. Uh, coordinate proof. Coordinate proof is another type of proof that we can use. So we've done two column, we've done paragraph, we've done flow, now we have coordinate. Um, and what happens is it uses uh, the coordinate plane. So it puts a geometric figure, triangle, square, what have you, rectangle, into a coordinate plane. Um, it uses variables, no numbers. It uses variables for coordinates, which makes sense. We don't want to use numbers. And the thing about coordinate proof is that it has to be true for all figures or similar, not similar, figures. All it says figures of the type. We'll say all congruent figures or figures that are exactly like it. Okay. So coordinate proof, it puts a geometric figure into a coordinate plane, something like a triangle, square, rectangle, etc. Instead of numbers for coordinates, we're using variables. And the reason why we're using variables is because that makes it true for any type of shape that's congruent to the one that we've done or similar to the one that we've done. So things that they show you here in the types of coordinate proofs, which is kind of helpful. When we're drawing something like a square or a rectangle, if it's a vertical distance, so let's say this is the rectangle. So things that we need to know about a rectangle is a rectangle has a pair of congruent sides that are parallel. So if this is K, right, then this is also K. If this is H, then this is also H in terms of distance. When we put it in a coordinate plane, actually let me put it in blue or pinky. When we put it in a coordinate plane, oh Lord. Like so. So my X, here's my Y. To denote a vertical line, when we do our coordinates, the Y coordinate changes, but the X coordinate stays the same. We always start at the origin. That would be a good idea for you guys. I mean, you can start wherever you want, but it makes more sense to start at the origin to have a pair of zeros. It makes the algebra and the subtraction easier. Since this distance is K in the Y direction, then this changes. Since it's a vertical line, the X coordinate does not change. It stays the same. And this turns into K. Here, if we're going in the horizontal direction, the Y coordinate does not change. So if Y is 0 there, Y is 0 here. And the H changes because we moved the distance of H. Since we moved the distance of H here and we moved up a distance of K here, our X coordinate is going to be H because we moved the distance of H, and our Y coordinate is going to be K because we moved up the distance of K. So you have H and K. So these would be our four types. Vertical lines, the K distance changes, the X distance stays the same. Horizontal distances, our X distances change and our Y distances stay the same. Here we combine the X and the K because it's parallel. So if I was to subtract here, this would be k minus k, h minus 0 would be a distance of h. This would be h minus 0, 0 minus 0, this would be a distance of h. This would be k minus 0, 0 minus 0, distance of k. H minus h is 0. K minus 0 is 0, distance of k. So it works. They also did a scaling triangle. So this one is doesn't have a vertical line or a vertical component to it. It only has a horizontal line. So that still stays true in terms of a horizontal line. In most of these figures, we do deal with a horizontal line at the base because it makes the math a lot easier. So we have the distance from here to here. This distance is d. This is the origin at 0, 0. Let's make this longer. So this is moving in the h direction. So the h direction is d, and this guy would be 0. We're not moving in a vertical direction. We're moving up here in this direction. We're moving up here in this direction. So it goes up to the right a distance. Let's put d over here. This guy. Let's put d over here. They call this FG. And that's because it moved a horizontal distance of f, and it went up a vertical distance of g. So x distance went f, y distance went g for that point, so it's fg. Okay. This one went a distance of d, and since there's 3 sides, we have 3 points. And we're going to use this way of setting up our coordinates to prove things in coordinate proofs. Namely, we're going to be proving the midsegment. It says in example 2, I guess I'll go back. It says in example 2, F is the midpoint of CB. What do you know about DF? All right. It says F is the midpoint. Example 2. Oh, I'm not worried about that part. Okay. I was looking at the wrong thing. Show another way you could place the rectangle part E and part 3. That is convenient. They're asking you to rearrange this another way. You can just rearrange it in any ways that's going to help you find your variables to help you do math. So we'll talk about that in a second. It's possible to find any link side in example 3 without using the distance formula. Explain. So when we talk about finding the distances, between these parts on the triangle, we can use the distance formula. So I will erase this. So I'm looking at this triangle. We can use the distance formula. Remember, the distance formula is x squared. I'm sorry, x1 minus x2 minus x1, I believe. It doesn't. It could be y as well. Plus y2 minus y1 square root. This works really well with uh, uh, lines. It's like slanted lines or lines going in an upward or downward direction. So I'll say slanted lines. This works really well with slanted lines. But we can use something else. We can use also the ruler postulate. We can use the ruler postulate. And the ruler postulate is the absolute value of, let's just use the x coordinate, x2 minus x1, right? Or in the y direction, we can say y2 minus y1. Instead of adding them up and squaring them and subtracting, squaring, and adding them and square rooting, we can do the ruler postulate. The ruler postulate only works with horizontal and vertical lines only. Only. Distance formula can work with actually I'll take out slanted lines. We'll work with all types of lines. All lines. Okay. Ruler postulate. Horizontal vertical lines only. We learned the ruler postulate in chapter 1. Distance formula, all lines. So when we look here, and I have this horizontal line here, I can use the ruler postulate. And I can say, since this is 0 and this is 0, they cancel each other out. So I can just say the absolute value of, what? Absolute value of d minus 0 is d. So I can say the distance is d using the ruler postulate. I can also use the distance formula. I can say d minus 0 squared plus 0 minus 0 squared, but you see where I'm going with this. When I use the distance formula on the horizontal and vertical lines, these guys will always have a 0 squared, which is why we like to use a ruler postulate, which is d squared plus 0 squared square root, which is d squared square root, which is d. I get the same answer. If you forget about the ruler postulate horizontal and vertical lines, you can always just use the distance formula to confirm, or if you're not comfortable. However, though, if I wanted the distance between F, G, and DO, I would have to use the distance formula. So let's look at that. So this would be, I'll call this my 2's and this my 1's. F minus D squared plus G minus 0 squared square root. So this would be F minus D squared plus G squared square root. And this would be your answer. That's all I can do. If I wanted to do Fg minus 0, 0, this would be F minus 0 squared plus G minus 0 squared square root. This would be F squared plus G squared square root. Again, that's all I can do. And this distance formula works for all lines. Ruler postulate we can use on horizontal and vertical only. It asks me that it tells me that a square has vertices, blah, 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 blah. Find the fourth vertex. All right, so if we know what a square is a quadrilateral such that all four sides are congruent and both pairs of opposite sides are parallel. So I have this guy and it goes up to here. Here we have this guy and it goes up to here. not to scale. This guy that goes up to here. The first coordinate it gives me is 0, 0 at the origin, which makes sense. And then we have m0, so this is in the horizontal direction because the m has changed. And then they give me 0m, so that's the vertical distance because the vertical distance has changed. Since I'm going to the right m or horizontal m and I'm going vertical m, this fourth guy would be mm, which represents the vertical change, right? This is m, then this is m vertically, represents the horizontal change. If that's m, and that's m horizontally, so m to m, it would be mm. Okay, so we just talked about the midpoint distance formula versus ruler postulate. We can also talk about the midpoint since this is the midsegment theorem. So when we have, I should have did it in the previous example too. When we have, actually, okay, when we have this triangle here, same thing from the example, and they say this is point O. Point O is 0, 0. Why would they give point O 0, 0? I don't know. Point Q, they give me KO, meaning the horizontal distance and change it, and point P, they give me OK. It's just OK. Then they give me a midsegment, and they give me a midsegment at point M. And if you recall, the midpoint formula, or not a midsegment, they give me a midpoint at point M. The midpoint formula, for those who don't remember, is x1 plus x2 over 2 and y1 plus y2 over 2. And we're going to use that here to find the midpoint of this thing here. So to find the midpoint, we just call these my 1s and these my 2s. So it'd be 0 plus k over 2. So I'm adding my x's right there. And then, k plus 0 over 2. How convenient. Which gives me k over 2, k over 2. We're going to use midpoints a lot with these coordinate proofs. So we also have the midpoint formula. Okay? We already talked about the distance versus ruler postulate. Here's the proof of the midsegment theorem. And the proof of the midsegment theorem says this. We have to do three things. I don't know if I want to draw this. No, I don't want to draw this. We have to they give us a triangle, OBC. They give me a midpoint at D, a midpoint at E, or they give me a point at E and D. Notice how they labeled their points. They labeled their points as 2Q, 2R, 2P over here. There's a reason for that, and the reason for that is because we're going to use the midpoint formula, and it's over 2. So we can set these up as we want. We could even say it over 4, over 6, over 8, and it'll give us whole numbers. So you can label these however you want. The book will say 2. I would recommend that as well because it limits fractions, and we don't want that because, you know, fractions. We love fractions, but we don't love them today. They tell me that these guys are the midpoint, or the midsegment. So we know what, so we got to prove that they're parallel in half. So we have to first do the midpoint formula for both of these. So midpoint of D coordinate and the midpoint of E coordinate. So what they do here is they say, okay, using the midpoint formula, they say that D is the sum of 2q and 0 over 2 in the x-coordinate, and 2r and 0 over 2, and that gives them 2q over 2, which is q, and 2r over 2, which is r. How convenient. And then over here, to find E, the midpoint is going to be 2q plus 2p over 2. And then the y part is going to be 2r over 2. Shorten it. All the 2's cancel, so this is 2q plus 2p. It's going to be q plus p as the x-coordinate and an r. So we're told it's the mid-segment, so we know that these two guys are the same. We use the midpoint formula that said this is in the middle. That's the first step. All right. Second step, we use the slope formula to prove that they're parallel. Remember the slope formula? y2 minus y1 over x2 minus x1. So in the case of the slope of DE, it doesn't matter which ones. Let's call, well, these are my y. So since it's a horizontal line, the slope should be 0. So r minus r over q plus p minus p, which is 0 over q, which is 0. So it's a slope of 0. And then the slope of the other one, we have 0, 0, 2p. So that guy would be 0 minus 0 over 2p minus 0, which gives me 0 over 2p, which is 0. Looky, looky. So both of the slopes are the same, so these are parallel lines. So we can say that DE is parallel to OC. Their slopes are identical. Isn't that special? Okay. Third step is step 1, 2, 3. We got to prove that DE is half of OC. So we got to use the, since they're horizontal lines, I can use the ruler postulate. But I think in this case, I'm going to do the distance formula just to show that it works either way. So you get the distance of this. This can be my 2's and my 1's. So let's call these 2's and 1's. So for DE, it's going to be q plus p minus p squared plus r minus r squared. And remember, this turns into 0. That's why you can use the ruler postulate here for horizontal lines. So this is going to be q squared, because the p's cancel, plus 0 squared, square root, so that's the square root of q squared, which is q. So the distance is q. Or is it q? Or is it p? Oh, minus q. Minus q, myself. So it's actually p. I'm sorry. P squared. And this is p. Okay. So that's that guy. So that's half of it, so it should be double. So let's get the distance of OC. OC is, we have 2p minus 0 squared plus 0 minus 0 squared. Again, this is why we use the ruler postulate, but I'm using the distance just to prove a point. 2p squared plus 0 squared square root, which is 2p squared square root, which is 2p. They're parallel, and we're proving that DE is equal to 1/2 of OC. Okay? Alright, so it says in example 5, show that F is the midpoint of OC, or F is the final coordinates OC. Alright, so this also wants to show that they're parallel. So there's this other guy F here. So let's draw the triangle. So this is 0, 0. This is 2p0. This is 2qrq. 2q2r, sorry. This is O. This is C. Now they're saying this is their other thing, F over here, and they're saying that F is the midpoint, or the F is the midpoint, and they want to show that these two lines are parallel. So we have F over here, and then we still have this guy at D. So this is D, and we proved that D is QR from earlier. No sense in going through that again. So we just have to find the midpoint of F. So for F, so step 1, find F. So the midpoint of F is going to be 2p plus 0 over 2 and 0 plus 0 over 2, which is 2p over 2, 0 over 2, which is p0. So this guy is p0. What they want us to prove is that actually, let me do this. Let's put it down here. P0. What they want us to prove is that line DF is parallel to the third side, which is BC. So for the second step, we have to find the slope. Find slope of DF and BC. Alright, so slope of DF. Alright, remember rise over run, y2, y1, so let's call these my 2's, and actually let's call these my 2's and these my 1's. Slope of DF. So let's go R minus 0 over Q minus P. Okay, so R minus 0 is R, Q minus P is Q minus P. So that's our slope. And then our slope of BC These are my 2's and these are my 1's. 2r minus 0 over 2q minus 2p. So that's going to be 2r over 2q minus 2p. Divide all of that by 2, and we get r over q minus p. These guys are the same, so they're parallel. And since they're the same slope, then I can say that DF is parallel to BC. Isn't that wonderful? Okay. All right. Graph. Is it a right triangle? Okay. They want to know. Y, X. We have coordinates. Why is it O for origin? I get it, but dang, man. Alright, so this is O, 0, 0. We're going to go up to the horizontal distance here. So the horizontal distance changes. So this is M and this is the same. This is point J. And then we're going to go up. So this is J. And then we're going to go. They want to know if this is a right triangle. So this is going to be M and N. So this is going up a vertical distance of N. They want to know if this is a right triangle. Well, in order to find something is a right triangle, they should have perpendicular slopes. So we're going to get the slope of MO or OJ. Slope of, this is point H. So to find out if it's a right triangle, find slope of OJ and HJ, and they should be negative reciprocals of each other. So if I was looking at OJ, slope of OJ, these are my 2's, these are my 1's, it's going to be M 0 minus 0 over M minus 0, which is 0 over M, which equals a slope of 0. Godly. Okay. For HJ, we have N minus 0 over M minus M, which is N over 0, which means that it's undefined. When you have two lines, one is undefined and one has a slope of 0, that means we're dealing with a vertical and a horizontal line. So this is horizontal. And this is vertical. Horizontals and vertical lines are always perpendicular. Horizontal lines are perpendicular to vertical lines. So this is a right triangle. Okay. Second thing they want me to do is find the side lengths and coordinates of the midpoint of each side. Alright. So let's get the coordinates first. So let's call this A. Let's call this B. Let's call this C. So that guy and that guy is the same. That guy and that guy is the same. This guy and this guy is the same. Let's put them together. Okay. So first thing we're going to do is find the midpoints of all three of these guys. So midpoint of A, that's going to be m over 2, m plus n, and n over 2. Alright, midpoint B, I'm eyeballing this. M plus m is 2m over 2, so that's going to give me m. And then n plus 0 over 2, which is going to give me n over 2. And then midpoint at C, that's going to be m plus 0 over 2 and 0 plus 0 over 2, so that's going to be m over 2 over 0. And I did that, I eyeballed it. I did mental math. M plus 0 divided by 2, n plus 0 divided by 2. M plus m is 2m over 2, which is m. N plus 0 over 2, which is n over 2. And then m plus 0, which is over 2, which is m over 2. 0 plus 0 over 2, which is 0. Those are the midpoints. Then they want find the side lengths and coordinates of the midpoint. Find side lengths. Okay, so they want the lengths of the sides of the triangle. So they want the distance. So for step 3, for HJ, I can use ruler. For OJ, I can use ruler. For HO, since it's a diagonal line, I can use the distance formula. So let's worry about HO first. But even that, I can still, since there's zeros, so that's actually pretty good. So distance formula for HO, which is m minus O squared plus n minus O squared. Which is m squared plus n squared square root. And I'm done. This is what it is for HO. Don't get tempted into saying this is m plus n because we treat this as a parentheses. We have to simplify the inside the radical first before we square root. And since that hasn't been simplified, we cannot do that. That is a common mistake in algebra. So the distance of OJ, again, I can use the ruler postulate for this one. So I can, since the zeros are canceled out, I can say it's going to be m minus 0 square root, and that's m. And then for HM, I can use the ruler postulate as well because it's a vertical line. The m's cancel, so this is actually n minus 0 absolute, and the distance is n. Alright, so that is this section. Hope you have a great rest of your day.